Doing the milestones for our feasibility plan was rather simple. As you saw before, Ethan, Mark, and Marquise did the first milestone, which was coming up with the feasibility risk during the task breakdown and resource allocation. Our second milestone was calculating how these feasibility risks would affect our system and if they were still risks at the end or not. The battery life compensation wasn't too much of a risk. We put each piece on a spreadsheet and saw how much power each piece would draw. In the end, we determined that it would have at least an hour of battery life, but it would not be able to go for 26.2 miles. As far as the car's weight, again, we put each piece on another spreadsheet, this time including the weight of the car's exoskeleton in pounds and the subsystems in ounces. We determined that the weight was a little under 20 pounds and that this would not be a problem. Finally, we made sure the car could function in inclement weather. We looked at the specs of the car on Amazon and saw the tires were large enough to where they wouldn't dip into puddles too much, and it had great enough tread where the car wouldn't spin out of control on a wet surface.
This is Marquise Brown of the IoT Prodigies here to discuss our battery life compensation feasibility risk. When thinking of feasibility risk for this project, battery life was our biggest and most immediate concern. If you look at the current slide, you can see the power consumption of all electronic devices which will be inside of our final product. Note that the phone will not be powered by the car. Upon inspection, we immediately knew the stock battery included with the electric cart would barely be capable of meeting our minimum requirement, which is 1 hour. This was unacceptable. We thought of potentially buying a larger battery for the vehicle, but we lacked the space to fit in a larger volume battery. We instead welded together two lithium ion batteries, which greatly extended battery life. Measuring with our new battery capabilities, our car now has a theoretical battery life of 2.4 hours. Keyword theoretical. We have not tested this in the field yet. This exceeds our desired results and solves the feasibility risk. It should also be noted that the two lithium ion batteries consume the exact same volumetric space as the stock battery.
Alright, so here's the ghost car with the battery leads attached to a clamp meter. What we're going to do is we'll have the ghost cart blocked by an obstacle. We'll be using the scale from the previous video, for example. And then we will turn the car on and let it try to spin the motor and the wheels under so to simulate a maximum load when it is being blocked by an obstacle. And we will measure the current draw using this clamp meter. So I will go ahead and turn it on. And then we wait. So right now the car is starting to drive forward and we're seeing peaks of 0.91 amps.
Hello, my name is Ethan Ellis. My feasibility risk was about the weight of the car. This is for two reasons. One, that it can't be too heavy for someone to carry, and two, more importantly, the car has to be light enough so that it doesn't affect the speed and the power consumption of the car. So to do this, we need to calculate how much the car will weigh and how much the power delivery system can handle, and make adjustments if necessary. So here's the calculation for the power consumption. At 20 pounds, the power consumption is just over the capabilities of the batteries. Um, and the weight of the car that we have comes to just under 15 pounds. So
Hey everyone, I'm Mark Fiddler, and my task was to make sure the car would still efficiently drive in the rain. One concern when coming up with risk for this project was what if the rain, the puddles cause the car to slide more, and how would that affect the peer pursuit algorithm and all these other different factors. So the first thing we wanted to do was to make sure that the car used larger wheels so it would stay elevated and the puddle wouldn't actually splash up into the car and affect the electronics inside of it. And we also wanted to make sure that the tires had better tread on them. That way, they're less likely to slip. Another thing we were worried about was hydroplaning. And hydroplaning, we did some research and we found out that um, because our vehicle is lighter, there's a greater chance for it to hydroplane, which is not great for our situation. And another thing we had found was um, oil residue on the road can also help create slippery conditions, but we still need to make calculations um, on like the coefficient of friction for our car, but we just haven't had time to do that yet.